Welcome to Study Loop.
Here we should first derive the work done on the gas, which is in relation to the change of the volume. So we know that the work done will be equal to the integration from initial to the final volume, pressure as a function of volume, times the differential part of the volume. When the pressure is a linear function of the volume or is constant, this can be said to be equal to P times delta V, which means that only the change in volume contributes to the work done, since pressure is not a direct function or some nonlinear function of volume. Therefore, when we actually want to find the change of the volume in itself in some process, some expansion, for example, or compression, we can find that knowing these two important variables, which are constant in this case, pressure and work. So first, let's see. First, we must make sure that the total heat exchanged is only related to the work done. And from the first law of thermodynamics, Q equals delta U plus W. So here we do have the internal energy change to also together with the work. But since the internal energy is the same at the beginning and at the end of the process, there is no change in internal energy, and this term here will equals to 0. So this implies that Q equals only the work done. Therefore, it is justified to say that the change in volume will be only related to the work done and the pressure in the next manner. So work done over the pressure, which are constant and they're given in this problem. So this equals minus 2.15 times 10 to the 5th power joules over 9.5 times 10 to the 5th power pascals, which is the unit for pressure. So this, when we put these values into a calculator, we obtain that the change in volume is equal to negative value minus 0.226 meters cubed. And this is the final solution for this problem. I hope you find it helpful, and I hope to see you in another lesson.